So 11.2, I'm going to give you a bunch of postulates and theorems, and we're going to use those to prove some things about parallel lines. So here's the first few. The first one is a postulate. It's called the same side interior angles postulate. And what it says is, if a transversal intersects two parallel lines, and that's the key, they have to be parallel, then the same side interior angles are supplementary. So, for example, using the image that's here, we could say that the measure of angle 4 plus the measure of angle 5 equals what? 180. And we would cite that as the same side interior angles postulate. Okay? The next one is a theorem. It's called the alternate interior angles theorem. So if a transversal intersects two parallel lines, then the alternate interior angles are congruent. So if we're talking about alternate interior angle theorem, we can say that angle 4 is congruent to, where's the alternate interior angle? Angle 6. So we can say that angle 4 is congruent to angle 6 using the alternate interior angle theorem. What other two angles could I say are congruent? 3 and 5. Good. Corresponding angle theorem says that if a transversal intersects two parallel lines, the corresponding angles are congruent. So using that theorem, I can say that angle 1 is congruent to angle 5. So the corresponding angles. I could also say 4 is congruent to 8, 2 is congruent to 6, and 3 is congruent to 7. Good. Not too bad, right? So here's what I want you guys to do. Now this also, I want you guys to recognize, does not mean that anything else goes away. So let's look at the examples. Let's do the page. So let's look at example 1. In example 1, I give you one angle measure. And I expect you to be able to fill all the rest in. So we're going to use those theorems and postulates that I just showed you to find the missing angle measures. But stuff that we already know for sure still applies as well. So if this angle is 51, could I also figure out what angle 1 is? Yeah, because they form a linear pair, which add up to 180. So you can use that. Could I use vertical angles? Yes. So here, I want you guys to work together. Figure out angles 1 through 7 for me. Measured angle 1 should have come out to what? Who got it? Rose, what'd you get? 129 degrees, right? Yeah. Uh-oh. Oh. Duh, it's on freeze. Okay, measure of angle 2, what'd you get, everybody? 129. Measure of angle 3? 129. 4? 51. 5? 51. Oh my gosh, you guys, I know all of you got this. What about 6? 129. And 7? 51. Any questions or concerns about how we got these? Okay, so let's go through it. Let me go through it really, really quick. So here's 150 or 51. So what I always do is I always put the congruent ones in first. So I know that angle 7 is congruent to 50 or is 51 because they are what? Vertical angles. I also know that angle 5 is 51 because they are corresponding angles. And 4 is congruent because it's vertical to 5, right? We could also say it's corresponding to 7. Okay, so those are all the 51s. I got 129 because 51 and angle 1 are a linear pair, which means they're supplementary. So you just subtracted from 180. And then I also know that angle 6 is 129 because it's vertical to angle 1. Angle 2 is congruent to angle 6 because they are alternate interior angles. If you used a different reason, that's okay. And then angle 3 because it is vertical. It's also corresponding to 6. It's also an alternate what to angle 1? Exterior to angle 1. There are lots of different reasons. There's a lot. Okay? So let's do number 2. Do number 2 for me really quick. Okay, guys, we're going to do this one a little differently. We're just going to go straight down the line. So here's 120. I want to know angle 1. What type of angle is angle 1 compared to 120? Corresponding. So that means they are the same. So a measure of angle 1 is also 120. Okay, let's look at angle 2. Jen, you got 60. How'd you get 60? It's a linear pair with angle 1. We could also say that angle 2 and this 120 are same side interior angles, which means they're supplementary. Okay, so there's 2 reasons. What about angle 3? Who got angle 3? Rose. Okay, how'd you get that?
Because
1 and 3 are vertical angles. Good. Also, what's another reason? Who can figure out another reason? Jen? Opposite side. Interior, so that's alternate interior. What you can do is extend this. This one and this one are alternate interior. These are vertical. 4, angle 4, what'd you get? 60. Mackenzie, why? There's a couple different reasons. This one, angle 4. You said 60, why?
Yeah, but like what other angle?
It doesn't matter. Pick. How'd you get 60? Vertical angle to 2. So angle 4 is vertical to angle 2. Christian, what's another reason? 4 and 1 are a linear pair, so they are supplementary. Mackenzie?
Oh, I'm just gonna say.
Okay. And that's all we have for right now. There is one more, but we can't use it because we don't know what this one is yet. But that's the reason we can use for this one. So Jen, what is angle 5?
It's 60.
And why?
Because they're opposite side.
Okay, so it's not opposite, it's alternate.
Alternate side, exterior.
Alternate exterior angles are congruent. Another reason, it is a linear pair with 120, so they're supplementary. And I have one more reason. Who has another one? Daniel. Corresponding with angle 2. Good. So do you guys see? So the reason why I want you to be able to tell all these different reasons is because when we get to a proof, like we're going to do right now, depending on what's given to you, that's going to determine which reason you can use. Okay? So we're going to do this one together. You ready? First thing, I forgot to number the reasons on the right, so there should be a 6 and a 7 there. That's my fault. So let's look at the picture and kind of brainstorm what it is we want to do first. First, they tell us that angle A is parallel to angle B. We could also tell because they have this little marking right there, which means they're parallel. And we want to prove that angle 1 and angle 8 are supplementary, meaning they add up to 180. So I want to kind of go through this. What are you guys thinking right now? How could we prove this? Talk with your neighbor. So knowing that these are parallel and knowing we want to get that 1 and 8 are supplementary, talk with your neighbor. What are some ways that we could prove that? It will always be the first statement, the given. So it's going to be A is parallel to B, and the reason is that it is given. That's my favorite one. I know. Okay, so then I say angle 1 is congruent to angle 5. How do we know that? Corresponding angle theorem. You must put that. So corresponding. You can't just put corresponding angles. You have to put corresponding angle because it is a theorem. Is corresponding 2 R's, not 2 O's? Just put, you can, corresponding angles. You can abbreviate theorem. Okay? Corresponding angles theorem. Okay, so then this one wants you to fill in the statement, and it says congruent angles have equal measure. So that tells me from this, we want to put it in measure form. So instead of saying angle 1 is congruent to angle 5, we would say measure of angle 1 equals measure of angle 5. Why do you think we have to do that? To show that they're supplementary because they add up to 180. So that's our next part right here. The next reason that's given is that angles that form a linear pair are supplementary. So which two angles are forming a linear pair here if we're going to be using angle 5? 5 and 8. So we would write that as measure of angle 5 plus measure of angle 8 equals 180. What? You're right. So what did I put?
Maybe measure of angle 8 plus.
You're right. What did I write then? Hold on. Because I think we could go straight. But 8 and 7 is irrelevant to us. Oh, I think it just states angle 5 and angle 8. Yeah, it just states angle 5 and angle 8 are supplementary. Okay, and the reason why... Okay, there we go. The reason why we have to put that is because it's showing that they're a linear pair. Okay, so we're saying we know they're supplementary because it's a linear pair. And because they are supplementary, that means that the measures add up to 180. So for number 5, that is the definition of supplementary angles. And this was on your test when we did the test. Okay, so what this is saying is we're showing that they're a linear pair, therefore they're supplementary, therefore they add up to 180 by the definition of supplementary. Does that make sense? So we have to do all the in-between steps. So then they say that the measure of angle 1 plus the measure of angle 8 equals 180. What did they do there? They substituted angle 1 for angle 5. So that is substitution. If you put transitive, I think substitution is more correct, but transitive isn't necessarily incorrect, but I think substitution is more correct. Okay, so then if the measure of angle 1 plus the measure of angle 8 equals 180, what did we just show? Angle 1 and angle 8 are supplementary. And what reason can we give for that? Same as 5, definition of supplementary. What? Yep, because that's what you're proving. I didn't say same side. I said alternate exterior. You can't use same side exterior because that's what we just proved. So now we just proved that opposite or same side exterior angles are congruent. We did. I don't know if it's necessarily an actual theorem though. There's a corresponding, an alternate interior, a same side interior, and an alternate exterior, but I don't think there's a same side exterior angle theorem. So we just, so in this picture, I tell you that A is parallel to B. So these two top ones are parallel, top and bottom. And C is parallel to D, so the left and right are parallel. I want you to prove that angle 1 is congruent to angle 3. These kinds of problems are tricky because we have two sets of parallel lines and two transversals. The transversals will not always be parallel. So it's going to be a little tricky. One thing I want to point out to you guys, notice how number 3, the reason is that it's given. So that means we're going to do just this first part first, and then we'll pull the second part in later. You see what I'm saying? So in the given statement, the very top number 1, we're just going to work with A is parallel to B right now. And that is given. And the reason why is because it says given in number 3. So that means that's where we're going to pull in C is parallel to D. Okay? So A is parallel to B and it's given. So we're just working with this part right here. And it says that angle 3 and angle 2 are supplementary. So that's using this transversal. So what would be the reason for that? Same side, interior. Is that a theorem or a postulate? It's a postulate. So same side, interior, postulate. Okay. So number 3, sorry, I just need to stretch a little bit. Number 3, the reason is given. So what's the other given statement? C is parallel to D. And then it says angle 1 and angle 2 are supplementary. So let me erase what I have right here. And let's do the next part. So we're talking about C is parallel to D, and it's telling me that 1 and 2 are supplementary. And Lily says, isn't it still same side interior? Do you guys agree? I agree. It is still same side interior. We're just looking at different lines. Okay, so let's think about this. I know that I want to prove angle 1 is congruent to angle 3. What could be the reason? So if 2 and 3, let me erase it again. If 2 and 3 are supplementary, and 1 and 2 are supplementary. Therefore, 1 and 3 must be congruent. What would be the reason? What do you guys think? I think Christian said it. What did you say? Transitive property of what? Congruence. Okay, so remember that saying that if 2 and 3 add up to 180 and 1 and 2 add up to 180, therefore 1 and 3 must be the same, right? That's transitive. Okay. Last theorem that I'm going to give you for today is the alternate exterior angle theorem. The alternate exterior angle theorem says if a transversal intersects two parallel lines, then alternate exterior angles are congruent. So, for example, angle 1 is congruent to angle what? 7. Okay. Angle 2 is congruent to angle 8. So here's the last thing that I want you guys to do. I'm going to have you work a little bit by yourself. We'll do the last two together. I want you to do 5 and 6. So here's kind of what I'm looking for. I give you this figure. I want you to find the measure of angle 3 and tell me what's the reason. So using the information that's given to you, what's the reason that you can determine at angle 3, and then what is the measure of angle 4, and give me the reason. Do the same thing for this one. We'll go over them. I'll give you just a couple minutes, and then we're going to do 7 and 8 together. Oops. No. Okay, so number 5. I give you that this angle is 105, and I want to figure out the measure of angle 3. Who got the measure of angle 3? Lily. 105. And what reason did you give? Alternate interior angles. That's really the only interior angle theorem. That's the only... Yeah, that's really the only one that you could give because I only gave you angle 4 or angle 105. Who got angle 4? Mackenzie. 75. And how did you get 75? Same side interior. Good. Same side interior. Isn't that a postulate? Yeah? Okay. Postulate. Okay. All right. Number 6, I give you 2 angle measures. One is 80 and one is 70. So who got the measure of angle 1? Somebody different. Did you get it? 100. I agree. What was your reason? Same side interior. Same side. Good job. Interior angle postulate. I know. Here's a trick that I use sometimes, guys. I will extend the lines so that you can kind of see better. Yeah, it's helpful. So if you're having a hard time visualizing because the lines kind of end, just extend them because the reasoning is still the same. Okay? Who got measure of angle 2? Angle 2. Lily. 70. And how'd you get 70? Corresponding to which one? It's not corresponding to numbers. You're right at 70, but it's not corresponding. Alternate interior.
There's a 70 there. I used a vertical angle.
Oh, okay. I see what you're saying. So she's saying that she used vertical angles here and then did corresponding. That's fine, but just because you're using the information that's already given to you, so I would say alternate interior is more correct. But you're right, your reasoning is correct. That if we knew what that missing one was, it would be. Okay? Okay, so then the last thing we're going to do is I'm going to give you a picture, and we're going to actually use what we know to solve for the unknowns. Jen? Okay, so why don't you help me? So, this is where it gets tricky because sometimes we cut an angle, so it's going to be a little trickier. What'd you do for number 7?
Well, I found at the bottom of the triangle.
Okay.
Because it would be like the same alternate side interior. So that one would be
40. Okay, so Jen is saying she found that the bottom of the triangle was 40 because it would be alternate interior. Okay.
And then I added 80 and 40 together and got 120. Subtracted that from 180 to find the
So y equals 180
minus
minus 120. So you got y equals 60. Do you guys agree? Let me check my work. I got 60 also, but I did mine differently. Did anybody do theirs differently? Christian, how'd you do it?
I did the alternate interior angle theorem up with 80, so I found the one triangle.
Okay, that's similar to what I did. So Christian is saying what he did. I'm going to erase this. He got that this one was 80, right? Using alternate interior angles. So then he knew that 40 plus y had to be 180. Or 40 plus y had to be 100 because this whole angle was supplementary to that one. Does that make sense? You guys see what he's saying? Okay, let me explain it a little differently. I actually did mine similar to Christian's, but skipped one step. So here's what I did. You guys notice if we forget about this line for a second, so pretend that this diagonal line is not there. This angle is same side interior to 80, right? You guys see what I'm saying? Which means they add up to what? 180. So 40 plus y plus 80 equals what? 180. You following me? Okay. Then you can combine like terms. So 120 plus y equals 180. So y equals 60. Multiple ways of doing things. So Jen used triangles. Christian did the exact same thing, except he did alternate interior to make a linear pair. I just used same side interior, but we did basically the exact same thing. Any method is correct as long as I can tell what you're doing. So you must show your work. If you don't show any work and just put y equals 60, I am not going to give you points. Yes? I do want it on a separate piece of paper because you're going to turn it in. Good question. Let's do the last one. The last one has 2 parts. We have to solve for x and for y. Let's do x's first. What do you guys notice about, I'm going to extend these lines. Jonah, what do you notice? These are parallel. Yep, the top and bottom are parallel. That's given. So what could we do to solve for x?
Wait, I got one good idea.
Okay, what's your idea?
What if 2x is same side interior to x minus 12?
Yep. So she said that 2x is same side interior to x minus 12, which means they are what? Supplementary. So 2x plus x minus 12 adds up to what, guys? 180. So this one plus this one equals 180. So solve for x. I need to move this now. It's getting in the way. So what'd you guys get for x? 64? Okay, that's what I got too. Do you guys see what I'm saying? You guys got it?
So then 2x plus 3y also
Okay, so good question. I'm glad you said that. So then Lily said, so therefore 2x plus 3y must also be supplementary. Not necessarily. Does anybody see why? Emily?
the two sides are because they're going to interact.
Yeah, I know what you're trying to say. These two transversals are not parallel. So we have no idea if they are opening at the same angle. Do you know what I'm saying? So what we have to do is, now that we're talking about the y's, we have to forget about this one for right now. So what could we say about the y's?
3y plus.
Yep, 3y plus y plus 20 equals 180. So solve that one. Huh? So you guys, I got y equals what? 40, good. 40 or 40 degrees? 40, why not degrees? It's only a variable, it's not by itself, so it's not the angle by itself. Good. Are you guys tired? Okay.